Today we are going to have a code walkthrough of this game called Dodge Lasers. It's made in JavaScript using the phaser library, and the purpose of the game is to, guess what? Dodge lasers. So I'm developing this game because I want to train a neural network to beat it, and it's a very simple game. There's only one button, the space bar, which causes you to accelerate upward. There's a force of gravity constantly pulling you downward, and I want to train the AI to beat that. So let's get started. We're going to code it from scratch. So you want to have a working directory. You can see I have one here. It's called Dodge Lasers. Assets contains all of your graphics. You want your game.js file and your scenes also. Phaser.js, you can use either phaser or phasermin.js. And I'm also using this p5.js library, which I think is like a math library. I only use it for one purpose in this game. I use it to create a Gaussian distribution of laser velocities. As you can see, all of these lasers come out at different velocities, and it's actually a Gaussian distribution. So that's why I have this p5.js library. So if you don't have the phaser library, just go to phaser.io/download, which will take you here, and then just click this thing, download phaser from GitHub, and then you can get min.js or JS. I think this one is just like takes up less memory. I don't know, but they basically do the same thing, I think. So go ahead and download that, put that in your working directory, and then if you want to be able to play your game in your browser, like I'm using Chrome right now, you have to actually use a web server for security reasons. So I'm using this web server for Chrome. I choose the folder, web dev, in my case, Dodge Lasers, open, and then you just type here, and it'll take you straight there. And as you can see, I have nothing because this is the empty working directory where I actually haven't written the code. Previously, it was pointing to the previous version of the code, but now I'm rewriting this code for everyone. So here we are. So the first thing that you do is create your HTML file. In my case, it's here. So it's like, this is the only thing I'm not coding live because it's pretty straightforward. You're just basically just including all the JavaScript files. Okay, so now we're going to go straight to game.js. So this sort of creates like the framework that the game follows. So you have this initial variable. I'm calling it gSettings. It kind of reminds me of a Python dictionary. The way it's structured, you have like key value pairs. Player speed, I started at 0. Max, lasers, we'll start them at 0, like I said, and then the maximum number of possible lasers will increase as the game goes on. Spear every 20 frames, create a new spear. Spear prob 1.0. So every 20 frames there is 100% probability that a frame will be created. That's what that is. Spear average vel. This is the average velocity of the spears. This is for fitting the Gaussian distribution of spear velocities, like I was saying earlier. Spear vel std. That's the standard deviation. That's also a parameter that the Gaussian needs to use. So 450 frames per second, I don't know what the units are, plus or minus 200. Those are the parameters for the Gaussian distribution. State alive. So state variable is just tells the state of it's like the game state, it's the state of the player. This player is alive. Var config every phaser 3. This is phaser 3, by the way. every phaser 3 game needs this variable. Width 800, height 600, background color black, scene 1, scene 2, scene 3, pixel art. I don't actually know what that does, but I have that there. True. Enable, and we want to enable arcade physics, which is very lightweight and good for our purposes. Some specifics. Default arcade specific, whoops, arcade specifics false, debug false. So we can just, oh wait, what happened? Why isn't it working? Let's see. Oh, I closed the web server. There we go. So you have to leave the web server open, obviously. Scene 1 is not defined. Oh, okay, yeah, so this won't run actually yet. So I have to go into my individual scenes and declare them. Class scene 1 extends phaser.scene. So it's inheriting all the properties of the parent class, which is the phaser scene. And you just want to do this for every single every single scene here. Class scene 2, class scene 3. None of them do anything. Does my code run now? Yes, it runs and it does nothing. Okay, so scene 1. This is the boot screen. So let's go into the boot screen here. Constructor super boot game. So super makes the class inherit all the characteristics, okay, of its predecessor of the parent class, okay. So we have that. Now we want the preload, do the preload function. Whoops. Preload. So the preload basically just is a function for loading music and images into memory. So background is the string that identifies the image. So what I mean by that, this.load.image background, it's located in assets/background.png. So here in this folder, this is the background I drew. It's very simple. It's just literally just a bunch of green stripes on a black background. You saw the game. So I'm loading that image. This is the handle. If I want to reference this, if I want to use this, which I do later, and then I just load other images in. Yeah, let's just player assets/player.png. Then I want spear. So actually, in the other version, I was calling all the lasers spears. So I'll just stick with that terminology, spears, because actually that's the name of the image, spear. The image for the spear is located in assets/spear .png restart assets slash restart.png, and that's it. Those are the only images. It's a very lightweight game. Then I have the create function, which is used to add objects to the game. So actually, do I need anything in there? I don't think I need anything in here. This is just my start menu, and I'm thinking of just not having anything here. Yeah. I think I'm just gonna jump straight to the next scene. If game settings dot state equals alive, then just do this dot scene dot start play. So this was going to be a start screen, but I think I can add that later if I want to, which I don't even need one. So this is literally just going to jump straight to scene 2. Scene 2, which is the main game scene. This is where all the action happens. So the first thing I need is the constructor. Super play game create. Okay, so when I create, I want to create the background. This dot background equals this dot add dot tile sprite. That's the position. The width is the width of the screen. Oh no, sorry. What are these parameters? I don't actually know. Oh no. Oh no, sorry, yeah. It's the width, yeah. The width and the height are. And then now I have the handle to the background image. So now I have this is just, it's referencing the class scene2. So it's scene2.background. So this is a variable specific to this class, is equal to this tile sprite, which is leveraging this image in the 0, 0 position, and it's as wide and it has the same dimensions as the screen. Config dot height, right? Okay. So, and then another thing I want to do is this dot background dot set origin. This is actually not necessary because I'm not going to be rotating. What it does is if you were to rotate the image, this is like the pivot point. It rotates around this point. Let's just run this again periodically to make sure no errors occur. No errors. Okay. So now what I want to do is make the player a physics object with a handle to the player image. This dot player equals this dot physics dot add dot image. Oops. 10. So X position, Y position, I'm putting it right in the middle of the screen, on the left of the screen. That's where he's going to be stuck. And I want to handle to the image. And that's it. And then what I say is dot player. This actually might not even be necessary, but that's okay. Set collide world bounds true. create a variable to listen for keyboard events. So I'm going to call this cursor keys. So this will listen to shift, space, and all of the arrow keys. Those are the options you can use when you use this input.keyboard.create cursor keys. It's kind of limited, but it's okay for our purposes. Oh, let's see, actually. So I want to, well, I'll do this later, actually. So let's see. This dot time equals 0. I want to track the number of frames, just because that's one way to score the game, is how long the player lives. Okay, so this is going to be weird. I have an array of tuples. A tuple in Python is, if you remember, it's like A comma B. You know, a tuple, it's like two entities, two variables. So an array of tuples would be like A1, B1, A2, B2, etc. like that, right? So I want an array of tuples of sphere objects which contain the data in the first element and the image in the second element. What I mean by that is like the image is actually the physics object that represents the sphere, and the data is some more like information about the sphere, and it's actually an object, the class of which I'll create later. So just hang on, just bear with me. I'll get to that later, but I'm going to call it this.spheres equals bracket. I also want to reset the player speed, because the player speed is initialized to 0 when the game first starts, but when you die and you restart, it doesn't go back to the game.js. It goes back to scene 2, sorry, and you want it to basically, you don't want the speed to be what it was when the player died. So I have to reinitialize it to 0. Max spheres. We'll start it at 2, even though eventually the real game it's going to be start at 0 and go up from there. So now we define the update function, which is basically it's the loop that runs constantly. It's the game loop, right? So let's just see if I didn't break the code. Did not break the code. Perfect. Okay, so I'm going to have scroll the background. So this dot background dot tile position X. Gravitational acceleration. So what this does is every frame it will increase the player's Y acceleration by 10, right? And that's the velocity is increasing due to the force of gravity. And when I have the player move, it's going to be decreasing it by 20 every time. So it's going to be exactly counteracting the force of gravity. Control the player's motion. It's going to be called this dot move player. This is a function I'll create. I also want to update time. Potentially generate a spear to attack the player. This dot spear gen. This dot spear del. Delete the spears once they reach the end of the screen. Display settings and check dead. Check if the player has died. So these are my So these are my functions, and I'll define them below. So move player. Control player motion. So if this dot cursor keys dot space dot is down, so right here, so I'm decreasing the player's speed by 20 when they hold the space bar, which will directly counteract the increase of 10 but due to gravity. So that will cause the player to slowly accelerate at the same speed as gravity when they hold the space bar. If we hit the top or bottom, kill the player. So I just know these boundaries. So yeah, this is pretty self-explanatory. The state is equal to dead. Set velocity y. This is a function that is inherent to arcade physics objects. So this dot player is an arcade physics object, and it has this function set velocity y, and I'm setting it to this variable gSettings dot player speed, and that's it. That's a really simple function. I'm gonna minimize it. So the next one is spear gen. I'm just gonna write them all out. Spear del. Disp settings. Check dead. Right. Okay. Let's do display settings real quick because that one's really, really, really simple. And for display settings, I'm actually not even going to go give a tutorial because it's literally just printing some things for the player to see. And you can just get it from the GitHub page. So it's shown here. It's literally just printing some status stuff, but you can go find the code and look at it yourself if you really care. So let's just move on to spear gen. What this does is every p frames, there will be a probability q that a spear will be generated with a velocity sampled from a distribution p. These p and q things are taken from these game variables, average vel and velocity standard deviation that I defined earlier. So let's do this thing. Var p equals spear every. Var q equals game settings dot spear probability prob. Var in spears equals this dot spears dot length. At every 750 frames, this is the modulus operator. So if the time divided by 750 has a remainder of 0, then it's the 750th frame, and what that means is that we want to increase the number of max spears by 1. Right. Okay. If this dot time, and now another one, every p frames, right? So it's the same thing. This dot time modulus p equals 0. If math dot random is less than q. Q is the probability, right? So math.random gives you a uniform possibility of getting something between 0 and 1. So Q is the probability. I set it to 1, so it's always going to happen. If math.random is less than Q, and also, and in spears is less than max spears, then we can generate a spear. So that's what this is saying, right? Var spear y equals 85 plus math.random times. So this is just making the y position of the spear a random location on the screen. The x position is equal to 800. It's putting it on the right side of the screen. Okay. And then what we want to do is sample a Gaussian distribution for the velocity. So the spear velocity is equal to, so this is the only, literally the only place in this code where this P5 library comes into play. Dot prototype dot random Gaussian. And you set the center to the spear average velocity, and you set the standard deviation to the spear velocity standard deviation. And then what you do is, and then what you do is add a new spear. Okay, so now here, this is where the structure of this spears array is kind of finally going to get explained. Do you remember when I created this array? Well, it's just an empty array, but it's going to be an array of tuples, spear objects, which contain data in the first element. So first of all, let's define the spear element, or the spear class before we get into this. So I have a class called spear. It has a constructor, and when you have a class with a constructor, what that means is that whatever the parameters for the constructor are the input parameters whenever you create a new instance of that class. So it takes the x and y positions and the x velocity for the spear. So I'm going to add new spears by populating this spears array. If you remember, I specified it earlier. It's an array of quote-unquote tuples. It's really an array of arrays, and each subarray just has 2 elements. One element is a spear object, and the other element is a phasor physics object. So what I do is I just do this .spears.push. That's adding a new element to this array. The first element in the array is in the subarray is new sphere, sphere x, sphere y, sphere vx. And then this dot physics dot add dot image sphere x sphere y sphere. I think I've overfit this problem, but that's okay. Okay, so the next thing we want to do, oops, is increment that variable by 1. And then what we want to do is we want to set the velocity of the phasor physics object so that this thing actually moves when it's on screen. So I say this dot spheres in spheres -1 because it actually starts from 0. It goes from 0 to the number of spheres -1. So this is the last sphere in the array, i.e. the most recent one. And this index 1 is indicating the second index in the subarray, which is the phasor physics object. And then I do set velocity x to this dot spheres in spheres -1 0 dot vx. Then finally, I want to add collider with the player game over upon collision. So this, I add another physics thing. It's called an overlap. So when the player overlaps with the most recently generated sphere in spheres -1 1 because that's the phasor physics object, this dot die. And this dot die is a function I have down here. It literally just changes the game state to dead. Okay, so that's actually the end of this function here, sphere gen. So I'm just going to minimize this, and we're going to go now to the delete function, sphere del. So in sphere del, let's start comments. This function will remove spheres, deleting the data in the array for that sphere and resizing the array. This will all be facilitated by the changing of the to delete boolean to true. In spheres, so I'm looping over the number of spheres, and I'm checking how far they are on the screen. And if the sphere reaches the end of the screen, destroy it. If this dot spheres I, 1 dot x, so the x position of the phasor physics object is less than -27.0. Trust me, that number just works. set to delete equal to true. Okay, and then accommodate the fact that the array length is changing by decreasing the iterator variable I by 1/2. Also break from the loop once the real end of the shortened array is reached. So then I say while I is less than n spears, increment I by 1. Now, because the length of the spears array could change, if I delete some of the spears, then what I do is if I is ever greater than, or equal to, for that matter. That's a bug in the original code. This dot spears length -1 break. So yeah, this is just accommodating the fact that if the length decreases because I've deleted another spear, this incrementer I is eventually going to go outside of the array length, and that would cause an error, so I just break from this loop if that happens. Okay, actually this should just be greater than, not greater than or equal to. It wasn't a bug. It was fine. It was fine. If this dot spears this dot spears I 1 dot destroy phaser physics object. Or maybe it just destroys the image. I'm not really sure. I think it just, in any case, that is the function inherent to the phaser physics class. This dot spears dot splice this will remove all data for this spear from the spears array. And then last but not least, I minus minus. Because, like, let's say we just deleted spear number 3. Now spear number 4 will become spear number 3, and spear 5 will become spear number 4. So you want to, at the next loop, start at number 3 again. So you have to decrease I by 1. And that's the end of that one. The end of this function. So I'm going to go ahead and minimize it. We're almost done. Almost done. Or are we done? Oh no, we still have check dead. And I'm just going to copy and paste from the original code. If the settings, if the player is dead, then go to the game over screen. And for the game over screen, I am literally just going to copy and paste. So this is one cool thing. So when I use this function called this.scene.start, I say game over, so it uses the handle for this scene 3, which is game over. But the cool thing is, here I'm passing some data from one scene to the other because I want the player to know how long they survived for. So here I can print, you survived for however many number of frames, right? So I pass this dot time over to scene 3. And then in the init function, I have this variable called data. This data is the data that was passed from scene 2, this dot time. And then I create another thing called this dot time in this other scene, and I set it equal to data, so that which allows me to print it. So that's pretty cool. And you can go on GitHub. I'll let you go through this. I don't think I need to belabor this very much. I just have I'm just displaying a bunch of crap, and it's pretty straightforward. And then if you either click the restart button or you press shift, it will restart, right? So that's how it works. I don't think we need to go into this. You can find it on GitHub. In any case, this is the old version of the game. This is the new. Let's see if it works. Let's test her out, shall we? 1 second. 1 second. And it's not working. Scene 2 is not defined. What is that? Okay. 137. Oh. Something with a... What did I do wrong? It's not quite clear what I did wrong. Oh, right. Silly me. Classes don't have these parentheses. And it's still not working. It's not throwing an error, though. What's going on? Okay, I figured it out. I forgot one simple thing. I need var game equals new phaser.game config. Ah, now it should work. Okay. Is there an error? Oh, set origin. Oh, I misspelled background. Okay, it works. Oh, huh. Why is the space key not responding? Did I do something wrong? Move player. Oh, whoops. This should be player speed. Okay, now it works. Oh, but that's weird. Why are they initializing SpearGen? Oh, this should be 800. Okay, there we go. See? There you go. It starts with 2. Oh, and I commented out the display settings, so let's put that back. Okay, so I had to create this .text, which is blank initially, in the create function, and now I can update it here at display settings. This .text.set text. It's showing the player's Y, it's showing the survival time, and the number of lasers. See? There you have it. And that's it. So it starts off with 2, and then once we hit 750, it will add a third laser. See? There you go. And now I want to train the AI to beat this. So, that's it for today. or for now. Maybe I'll append to this video or add. One more thing that I forgot. You can play music if you want. So in here I have this song called Spore Print Kryptonite, which is a song that I made in Linux Multimedia Studio. It's published on my SoundCloud. You can find the link below. But in any case, this is the background music that I had in the other version of the game. So let's just play that now. So I literally, it just plays it once and then it doesn't loop. It doesn't play it again, but that's okay. So it's in the create thing. I have this dot load dot audio music. Let's just copy that. Oops. And then I just do this dot music equals this dot sound dot add music. Oops. And this dot music dot play. So it just plays it once. And as you maybe be able to hear, I don't know. Let me restart it. I don't hear anything. That's weird. Huh. Huh. Well, I think there's something weird going on with my... Oh, yeah. When I have the microphone plugged in, the audio doesn't work. In any case, the music's playing. Just believe me. Yeah. So that's the last thing.